All right, good morning, everybody, and good afternoon, actually, now. Welcome to our another JAIN virtual Lunch and Learn. These have been going very well. Attendance has been very good. The comments we've been getting back on these has been excellent. So we're going to keep these going for a while longer. It's all part of our way of helping customers and prospects and acquaintances just move through this special time, this particular time that we're all going through for the first time. So we're trying to help that way. So anyway, we have a real treat today. We've got, but before I get into our presenter, I just want to mention that because this is a video lunch and learn, I've got all of you on mute. And so if you want to ask questions during the presentation, if you'll type them into the group chat, which you can find at the bottom of your screen. You'll see a chat button there, and I'll be looking at the different questions and asking those when appropriate, maybe during the presentation or during our Q&A session at the end. So anyway, we really do appreciate the comments and questions, so feel free to do that, and we'll try to get all of them answered. If there's any that we can't get answered, we will be following up with emails this afternoon. So again, thank you for joining. Our presenter today is Brad Holliday. And as I mentioned before, it's a real treat to have Brad presenting today. He's Territory Sales Manager for JAIN Irrigation. And he's got almost 30 years of agronomic experience. That's a long time to be working in agriculture. He holds a crop consultant license from the Oregon Department of Agriculture. He's been with the JAIN team for over 5 years now, working primarily in the Pacific Northwest. So he's been helping a lot of apple growers up there for a lot of years now. And I know they all appreciate his input and his knowledge. And it's great that Brad's going to share that with us this afternoon. So with that, I'm going to turn it over to Brad. Brad, good afternoon.
Well, good afternoon, Richard. And thank you, everyone. Good afternoon. And excuse me, as Richard mentioned, I'm the Territory Sales Manager for the Pacific Northwest. I cover Oregon, Washington, Idaho, and the western part of Canada. In my territory, it's probably split 50-50. I have quite a few row crops, onions, other vegetables, but there's also a lot of permanent crops, including blueberries, vineyard crops, cherries, hazelnuts, hops, and of course apples, which is what we're going to talk about today. Before I get too far down the road here, I just wanted to well, let me back up and say I want to talk today about some of the challenges that growers face in producing a high quality apple crop, specifically sunburn, and how our JAIN fogging system has helped some of these growers reduce the impact of sunburn on their apples. So, but before I do that, I just want to do a quick overview of, apple production globally, domestically, and then within within Washington State. For some reason, my screen will not go down. Oh, there we go. Sorry. So in the U.S., we have about 7,500 apple producers, and they produce those apples on about 322,000 acres. Just coincidentally, the U.S. ranks number 3 in the world in apple production, behind, of course, China and the EU. In Washington State, there's about 175,000 acres of apples, and which accounts for about 55% of the U.S. production. Some of the top varieties are Red Delicious, Gala, Fuji, Granny Smith, and Honeycrisp. And Honeycrisp, actually, for our JAIN cooling systems, we have really focused, the majority of our efforts have gone into the Honeycrisp, mainly because it's the value of that crop is generally much more than say a Red Delicious. Even though it's less than 10% of the overall production acres, we've done approximately 2,000 acres of cooling systems on Honeycrisp, and a little bit on Galas. So I'm not trying to change anyone's mind here. I really want to use this slide to make a couple points. This is some data that NASA has put out, what they've done. I don't know what the data points are specifically, but I really just wanted to show the trend of how climate change has impacted global temperatures, and specifically if you look, I don't know if you can see my cursor, but on the orange and red colors are really the last 20 years. So that's just an indication that we as an industry need to probably look a little more closely at some of these crops that need some type of cooling, that are a little bit more sensitive to heat. With that said, some of the major challenges for apple producers, and again, this is not an exclusive list, there's numerous, but these are just some of the ones that I picked. Labor, disease management, water management. Obviously, they want to maximize their yield potential. Part of that is how the temperature effects on the trees and the fruit, and then essentially sunburn. So again, I want to talk about these last three, which are really kind of the economics of how a grower would want to increase pack outs, or what ends up in the box that they can sell. So why would you cool? Well, a lot of varieties use for color, pigment augmentation, color development. They're trying to keep the climate around, the environment around the apple and the apple tree somewhere between 40 and 86 degrees in the last 4 to 6 weeks prior to harvest. Fruit size, it's important to try and maintain optimal growing conditions for trees. That typically is between 60 and 80 degrees. And then specifically what we want to talk about is sunburn, and how sunburn cooling can help increase the economics. And this is cooling to manage sunburn is very variety specific. It's, there's some apple varieties out there, as I mentioned, Red Delicious is one that may not have the value to justify a cooling system. So anyway, so why are we cooling? Well, we're cooling to combat sunburn. This is an example of an apple that hopefully this apple in the orchard would not even get picked. That's going to be garbage. So it probably will end up on the orchard floor before it even goes into the harvest bin. Some of the ways that you can manage sunburn, these are just four of the main methods that growers will use. They use shade cloth, chemical treatments, overhead sprinklers, and then what we want to talk about is the JAIN system. But just some quick examples of shade cloth. Here's a picture of an orchard that has shade cloth being rolled out. It's very expensive. If you think about a 40-acre, any size block, to cover that thing completely like they're doing here, it takes a lot of infrastructure, takes a lot of labor to roll it out, and then at the end of the cooling season to retrieve it. So it's very expensive. Chemical treatments, think of that as sunscreen for apples. It's relatively inexpensive. It does take multiple applications. And again, some varieties, you can't even justify doing something like this on apples. Overhead sprinklers. Probably the majority of the cooling that goes on in apple orchards at this point is overhead cooling. I would say it's probably 70% or more right now that are done with overhead sprinklers. This is essentially a full coverage sprinkler that people use. And this is one example. This is another example that, and a lot of them are done this way. And I apologize if you can't see all the details here, but this sprinkler has well, first of all, this line of tubing in the middle of that is the supply tubing for that sprinkler. And it runs throughout the orchard. What they'll do typically when there is not a cooling, when you're not in the cooling season, they move these up at the beginning of the cooling season or prior to the cooling season, and at the end after the harvest is over, they move them back to the ground, and they move them so 90%, probably 75% of the season, they're on the ground, and they're on the ground to irrigate the cover crop. Most of these systems have a primary source of irrigation for the tree, and people are moving more and more towards emitter line on each row. So one of the drawbacks to this type of a system is you have to move it up and down each time that you, or excuse me, before the beginning of the cooling season, and then at the end of the cooling season. So, and then the JAIN Fogger. What we're trying to do is create a fog layer over the orchard. And I don't know if you can see my cursor, but this is all on the trellis. This happens to be approximately 10 feet. It's more of a V, not a V, it's an inverted V, but a V trellis that there's tubing on the outside of each of these trellis, and the foggers down the row are approximately 15 feet apart. But what we're trying to do is create a fog layer at the top 2 to 3 feet above the canopy, or 2 to 3 feet within the canopy. There's just another picture of that. It's an interesting little story on this. As we were driving up to take a look at this system as it was running, I noticed on my pickup it was 100 degrees outside this orchard. And as we got closer and closer to this orchard, you could see the temperature of my truck drop, and it's dropped it by a total of about 20 degrees. So it just goes to show that we're trying to, and we're actually succeeding quite well in changing the ambient air temperature in and around these orchards. So the JAIN Fogger, what are we doing with the JAIN Fogger? Well, we're creating an environment, an evaporative cooling environment. So we're trying to lower the ambient air temperature within that orchard. There's, I guess, a scientific term, convective cooling, which is essentially using air movement to cool. And to some degree, there is some air movement with these foggers. It's always astonishes me when I go into these. They sound like it sounds like a hiss, and just the velocity of the water coming out of these little foggers creates a little bit of air movement, and enough for it to be considered a convective cooling. It minimizes the amount of water that we actually put on the fruit, and I guess I said that kind of twice here, but it decreases the applied watering rate within the orchard. And as an example of that is that with our JAIN foggers, we're somewhere between 15 and 20 GPM per acre on a traditional conventional cooling system with a full coverage sprinkler that, as the picture I showed where they move that up and down, that's somewhere around 55 GPM per acre, and that's a continuous flow. It's a 68% water savings.
Hey, Brad, Yeah,
Go
I
ahead.
just had a question. I see you're about to answer it. It was just, how much pressure do you need to operate these foggers? So you're going to go
Yep.
into that now.
Here we go. Perfect timing. Um, so with the JAIN Fogger, I guess to jump to your question, we typically like to see around 50 psi. Some of the other foggers on the market require 70 or so to achieve the water droplet size that we'd like to see. 50, 55 micron droplet size at 50 psi versus 70 psi, some of the competitors. And just as a reference point, the human hair is approximately 100 microns. So these water droplets are essentially half the size of a human hair. I guess at the top here, just finer droplet sizes, it makes it easier for the evaporative cooling to occur. And then filtration requirements, our standard is 120 mesh versus some of the competitors at 200. So essentially we're able to, well, they don't plug, let me say it this way, they don't plug as easily. I'm not saying that they don't plug, they just don't plug as easily as some of the other products out there.
Yeah, hey, Brad, I had another couple questions here I think that are appropriate right now. The first one is the inlet to the fogger. Is that a 1/4 inch tubing that goes on there? What size tubing goes over that?
It really depends on the system. If you're doing a long run, 1/4 inch tubing isn't going to cut it. I mean, we're carrying, quite a bit of water down that tube. Each of these is putting out about 3.6 GPH, gallons per hour. And if you have, 40 of those on a single line or whatever the number may be, 1/4 inch isn't going to cut it. Typically what we'll see quite a few on 1/2 inch, more and more on 3/4 inch, just to carry enough water to supply this system.
Yeah. Okay. And then we had another question here about the water savings and, what's the ROI on this type of application versus sprinklers?
Yeah, that's a great question. We haven't done all of the math on that. It's easy to say, we can save water. How much money we actually save in the end of that is still something that we're working to figure that out. One thing to keep in mind, we're running a pump at 50 psi versus 70. So there's some savings there. Again, I can't tell you how much that is at this point, but there is some savings in that respect.
Yeah, and I imagine too. I mean, if you're not experiencing the sunburn, you're going to get a lot more better quality, as well as more yield per acre.
Right, and that's really what it comes down to, right? We're talking about economics. Farming is all about economics, and in this situation with apples and apple packouts, you're trying to increase the number of apples that go into a box of apples that get shipped to, your local Vaughn store, Safeway, or whatever it may be. So it's really about the economics.
Right. These growers are some of the best business people I've run across in my entire life. So one last question, I'll let you get going. But what about the spacing of the foggers? What's the typical spacing of those foggers?
Yeah, and I'll get there in a second. I do have some typical, what I would say most common layouts, but so let me not answer that right now, and hopefully I'll be able to answer it here in about 3 or 4 more slides.
All right, you got it.
One of the other advantages that we have is we have multiple flow rates, and I don't know if you can see my cursor, but this blue nozzle is actually our 1.8 GPH nozzle, but if you have 2 of them, it's a 3.6 GPH. So application rates, we're able to customize, I guess is the right word, customize some of these cooling systems based on the infrastructure or the tree spacing, not tree spacing, excuse me. We're not trying to do tree spacings. We're not worried about tree spacing as much as we're worried about what's between row spacing is between all that. So with the 4 different flow rates that we have, we can customize that. And also, not only that, we can put a single fogger. This item down here is what JAIN we call a butterfly barb, but we can put a single fogger. We can put a T on this, which is what this is, a 2-way T. We can put a 4-way cross on it. And we also have the ability to put this bottom part, we can do a 1/2-inch male pipe thread. So we can customize these to different systems that are already in place. It's low maintenance in the sense that since this is all press fit products, you can if one of these does get plugged, you can take these off, these individual foggers off, without having to pull this whole assembly out of the tubing. You know, I think we've all seen, as soon as you pull something out of tubing, you're gonna make it elongated or something, and it's probably gonna drip. In our situation, if you have a plugged fogger, you can simply twist this one off and replace it with another one. If it's plugged up with something, calcium buildup or something within that fogger, you can just throw it in a bucket of some light acid, and it hopefully, you know, be able to clean it up that way. And the other thing to keep in mind with that is we're talking about these things being 15, 16 feet off the ground. And, you know, you probably want to minimize the amount of time you send somebody up on a ladder 16 feet off the ground. So it makes it for a quick and easy change if there's any ever problems on that. And then lastly here is just, it's a permanent fixed system. So in other words, once you put it up there, other than having to do some maintenance on it, you don't have to take it out, move it up and down like we did with some of these conventionals, roll it out with shade cloth or those types of things. Water requirements. So I mentioned before a typical, and this is a continuous spray system. So it's, in other words, it's not cycling or pulsing. You're using about 55 GPM per acre. If you do, and there is a lot of cycling. In fact, I would say the majority of the cooling that happens with conventional cooling systems is cycled to some degree. And in this case, you know, I just use the example, if you have 2 valves, you're essentially on half the time and off half the time. You're saving, you're only using about 27, 28 GPM per acre versus the JAIN Fogger, which you're using anywhere from 14.5 to 20 GPM. And even if you do cycle, it's still saving you about 34, 35%. And one point I really want to make, and this is probably the most important point, is that with the JAIN Foggers, if you decide to use a JAIN Fogger, they're most effective if you do not cycle. It's best for these things to come on whenever you decide to turn them on, and I'll get to that here in a second, but whenever you decide to turn them on, don't cycle these. They just do a better job cooling the environment, the ambient air temperature, if they stay on throughout the day. So here's some of the typical layouts. I hope this is going to answer the question that whoever asked that, but I would say 75%, 80% of what we have out there right now are these row spacings of 10 feet. There's a lot of apples planted on 10 feet, 11 feet, somewhere in that range. And we're on a 10-foot spacing, we're trying to go down the row every 15 feet. That puts the application rate at about 17.4 GPM per acre. Some other examples that we've done, we had an orchard up in Prosser where the row spacing was 10 feet, but there wasn't the infrastructure on what I would call this blank row here. There was no infrastructure that we could put a fogger up. And then we decided to put every 36 foot, they had a post, a permanent post that they used to put their trellis wires and such on. So we did it on what it turned out to be a 20 by 36. And when we did that, we did a 4-way fogger with an orange nozzle, which is the 3.6. So we had a 4-way 3.6, whatever, 14.6 for GPH per head per assembly, and it came out to about 14.5 GPM per acre. And then this bottom one here real quick is, it's an older orchard. There's not a lot of apple orchards that are planted on 17-foot row spacing anymore, but this is one that we retrofit and just wanted to give it a try and see how it worked. Grower was happy with it. So, and again, here's what we're trying to accomplish. Again, this is on about 15, 16 feet above the ground. You know, I mentioned if you had a plug on one of these, you can see you don't really want you don't want to be up on a ladder 16 feet above the ground too often, changing these out. At least in Oregon, it's the OSHA folks or the safety folks would probably be out having a chat with you. But that's what we're trying to do. We're trying to create this fog above the canopy. This is the one I was mentioning that's on a 4-foot stake. It is a 4-foot stake, but we use the bottom foot of this to attach it to the post. These were the posts that were every 36 feet apart. And we had a 4-way here at the top trying to shoot about 14.5 GPM out there. And again, this is just another picture of, you know, the fog layer that we're trying to create. I don't know if you can tell here, but the block on the right, actually the block clear on the right at the top, I guess it'd be the top of the screen or towards the middle of the screen. That's actually cherries. So we're not going to cool cherries, but on this right side here, this is a system or an orchard block that does not have cooling. And I don't know if you can see it, but there's a fog layer here over this apple orchard. To me, it looks somewhat like the shade cloth. Obviously, it's not nearly as thick, but it gives you the sense of what we're trying to do. It's just trying to create this fog layer over that block. So, cooling system, when do we start it? You know, typically these systems are up and ready to go sometime around the 1st of July. Every year is a little bit different, but you know, whether you have a conventional system or JAIN cooling system, you're going to want to have this up and ready to go by the 1st of July, in case you have a heat wave that comes in. And I mentioned earlier, you're really not going to cool a Red Delicious crop. Generally, there's not the money in it as compared to a Honeycrisp or a Gala. And then I put the Cosmic Crisp on this with a question mark. I think most people have heard about the Cosmic Crisp. It's the new variety that's coming, what's already in production. There's not a lot of acres. They had the first, went to the packing shed for the first time this last fall, and it's going to be a big hit. It is a big hit. So some of these higher end varieties are what you're going to cool. And then we want to measure. The growers have different methods as to when they want to turn this on. Some people will look at, excuse me, some people will look at fruit surface temperature. Other people will look at ambient air temperature. And what we have done is, in our work, we've used weather stations, and that's part of something that JAIN has invested heavily in the ag tech sector of the business, and we're able to, through our JAIN logic, we're able to create and utilize a platform that uses the technology, allowing for growers to take a look at whether it be wind speed, temperature. With this situation, we were able to measure temperature and relative humidity above the crop. And then we also ran some leads down and we measured temperature and relative humidity inside the crop. So we were able to see what kind of impact, the wind above the crop or even when we were cooling, what kind of impact we were having as we were cooling. You know, this technology, you're able to set alarms and different thresholds to help you manage your irrigation and the cooling system. And it gives you the ability to start pumps remotely. You can monitor your filtration, and you can open and close valves. And JAIN Logic can do a lot more than what I'm referring here, but that's just some of the things that we used JAIN Logic for in these situations. And then I guess finally, I just want to, I guess, Richard, I'll ask you if there's any questions, but this is my last slide here, just some of the other potential opportunities that we are looking at. You know, we're looking at pears. We've worked with and are working with Washington State to do some work with wine grapes. There's some work being done in California about chill hours for cherries and pistachios. And then also, you know, dust control for dust mites in hops and grapes. And this is specifically on dirt roads around the borders of some of these other hops and grapes. Dust mites love a dry, dusty environment. And so we're looking at using this type of a fogger to essentially all we're trying to do is put moisture out there so it's not as attractive to dust mites. So with that, there you go.
Hey, great job, Brad. Thank you. We've got a lot of good questions here. And that's always a good sign that you've got everybody thinking. So one of the first questions we have is about the cycling. You were talking about the cycling, and why do some growers like to cycle? What's the desired outcome there, and what's the correct way to do it?
Yeah, so on conventional overhead sprinklers, people will cycle. There's many reasons, but probably the biggest reason is that they don't have enough pump capacity to do all the acres that they want to do. So let's just say they have a 100-acre block and they only have pump capacity to do 55. Again, we're assuming 55 GPM per acre, and your pump only does, you know, whatever that math is, 2,500 gallons a minute. Well, to cover the whole 100 acres, they have to go back and forth between the two blocks to do that. So that's why people cycle. With the JAIN Fogger, since you're using less water, we're able to eliminate the cycling and still cover that. Whether it be 50 acres or 100 acres, you're still able to cover that because you're using less water.
Okay, great. Yeah, thank you. And then early on in your presentation, I believe you said that people are using this more on Honeycrisp than any other crop, or that's one of the most popular. Why is that? Is that strictly price, or?
Yeah, Honeycrisp is kind of a finicky apple to produce. There's a lot of techniques that people use, and everyone's got a different you know, secret sauce that they want to use on Honeycrisp. But yeah, it really comes down to economics. You know, the Honeycrisp is, at least at this point, is probably the most expensive apple that's on the market. It's one of the toughest ones to produce, and so logically, these guys want to put their money where they're going to get the best bang for the buck.
Right. Okay. Yeah, that absolutely makes sense. And now, mostly you've shown pictures of two-way fogger, but we have a four-way also. Is that right?
Yes. Yeah, we have a four-way. Let me get back here. And this is the four-way, and this was actually put on one of the. This is what at JAIN we call this an agri connector, and we're able to run this tubing up to it. It's got a half-inch on the actual agri connector. It's a half-inch female, but we are able to use a half-inch male adapter that has the press fit that we can put on to the put the foggers on and again customize some of these systems or according to what the orchard layout is.
All right, great. Yeah, thank you. And then the other thing I noticed is you had that one picture and you said these are cherries over here.
Oh
We
yeah.
don't really want to fog cherries. Some people are saying that maybe they do have a few customers that like to fog them. Why do people don't like to fog them? What are some of the advantages of? And
Well, I need to be a little bit more clear. You don't want to fog apples directly prior to harvest, right? Cherries have a tendency to crack. There is research being done to use cooling on apples to create chill hours, which is a completely different time of the year. In this picture, this cherry block has already been picked. This is in late July, maybe early August, and those cherries are in the box somewhere. But in general, during or close to harvest, you don't want to add excess water to cherries because they will crack.
right, okay. And then you mentioned the bit about chill hours.
Yes.
Are growers using foggers now to increase chill hours in the wintertime?
No, not in the Pacific Northwest. We're not. We have, and I don't know the exact definition of a chill hour. I think it's the number of hours below. I want to say 40 degrees. So if you have it in the Pacific Northwest, if you go to some of these apple growing regions, you may not get over 40 degrees for a month. So chill hours are not something we have to really worry about at this point. There is some conversation about using chill hours or creating chill hours in cherries in probably Northern California and in those areas.
Okay, great. Thanks, Brad. We have another question from a grower in the Southeast, and he's saying that we have high humidity in the summers. And how does the fogging work when it comes to somebody growing where the humidity is high and they're worried about disease?
Yeah, and that's a great question because, and I'll answer the question, but in the Pacific Northwest, in these apple growing regions, we have very, very low humidity. And so it makes the evaporation process much easier than somewhere where you have a high humidity, whether it be Michigan or some of these other locations. Again, we're cooling, the water temperature in and of itself is going to cool. Generally, you're not going to get water coming out of, you may, but generally you're not going to get water coming out of a fogger that's 90 degrees. So there is going to still be some amount of cooling that occurs. Using a fogger versus a conventional sprinkler for cooling, the disease pressure, there's still disease pressure. You're creating humidity and you're creating an environment where you could promote disease. But compared to overhead sprinklers, it's significantly less. I don't want to put a percentage on it, but you are going to, no matter what you do when you cool in a high humidity area, you're gonna create humidity, and that's not always good.
Right, right. So it's an alternative that reduces the risk.
Yes, yes.
Yeah. Okay, and then I had another question here about greenhouses. Are people using foggers in greenhouses now? Is this something that we could use these for?
Oh, absolutely. In fact, for those of you who don't know, JAIN owns Nandan JAIN, and most of this technology, if not all of this technology, comes out of Nandan JAIN in Israel. And that is what these coolers, we have a wide range of greenhouse products that we use for not only for cooling greenhouses, but for certain plant types that actually need fog as a to grow. So we have a lot of people using foggers, and if you ever go online, you can see the wide range of greenhouse products that we have, and this fogger that we're talking about is one of many different types of foggers that we have.
Okay, great, thanks. And we're down to our last question here, Brad, but you know, fogging that's used for cooling, do we actually add the water that's produced by the fogging to count to supplemental irrigation, or do we use a separate calculation out for the supplemental?
Yeah, no, this is not, I mean, there is some water that gets onto the orchard floor, especially if you start early where the temperatures aren't up. So all of that water is not being evaporated. But yeah, there is some amount of water that gets onto the orchard floor, but there's not enough water to really say that you're irrigating. It does, as I mentioned before, you are trying to maintain a healthy growing environment within the canopy or within the whole orchard. But in terms of, you know, water requirements or what's the word I'm looking for? Evaporation.
The ET, the evaporation transpiration,
Right.
the
Yeah,
amount
I'm
of
sorry.
ET applied that day.
Right. That I would not count this towards the ET.
Yeah.
So that's not, it's not significant.
Yeah, those droplets are just too really small, right, to reach the ground, or if they do, they evaporate very quickly.
Yeah. Yeah. It's like it'd be like walking on your lawn in the morning after heavy dew. It's that type of a moisture. You don't really, it helps, but it doesn't help enough.
Yeah. Well, Brad, gosh, great job today, especially with some of these tough questions, you know, but these were great questions. I appreciate your time into putting this together and then sticking around and answering these great questions. I want to thank everybody for joining us this afternoon. We're going to be back again on Friday to talk a little bit about landscape irrigation and the use of hermit crabs for landscape contractors. And we will be continuing this series on as long as we're sheltered in place on Wednesdays and Fridays. We're going to keep these coming at you. Some of the things we're going to be doing in the future too will include some panel discussions about what's happening with the ag economy or the landscape economy based on what we see or what we know from our experience and from the panelists' experience. So got a lot of good things coming up. So stay tuned. We'll be emailing that information out to all of you. Again, thanks very much for joining us today. And Brad, thanks again. I really appreciate it. And we'll talk to all of you soon.
Thanks, everyone.